As a programmer, you know, from time to time, you might want to actually get some sleep, you know. And what's nice about Notepad++, you can come back to it and there'll be all your files that you were working on. You don't have to be afraid to shut down your computer. In fact, it's ill-advised to just like use sleep mode all the time. I understand, you know, you want to reset your computer from time to time, initialize some variables, you know, because some careless programmer may have some endless loop going that will eventually overflow into other areas where you don't want it. Okay, so here, let's see, we made the state machine. Yeah, that was kind of cool, right? We started in mode 3. You could also, let's say if we went main, just main here, like that, and then set up our initialization like here or something, right? So whenever you go to main, you know, it's going to initialize it in this mode. And then down here on state 1, we could go to a different video mode, you know, like 256 color, you know. So you could have a simple text screen, you know, welcome to my cheesy game, you know, and then when you jump into state 1 now, you can play the actual game, you know, without text, you know, because maybe you might have briefly seen where text in 256 color mode is pretty dismal. You know, you have to make your own if you want any text in your game, you know. But I mean, just trying to make a game with the limited graphics is a monumental task anyways. But let us get on. Yes, let's just wipe all this out and start with a clean slate. So yeah, I also discovered, like, let me open this. It's already been doing some things and stuff. But if I'm in this file, it has an address. There, you can see it, right? But I learned you can just go, where is it? Open containing folder. Command, boom, launches a new window in the folder that you want. Okay, great, time saver. But of course, you don't have, like over here, I still have the stuff in memory, you know, where I've been programming my commands and such, right? So that you don't get. I tried the macros and stuff, and I guess you can record. I did a recording, and it worked, but then if I open a different file or something, it doesn't do the same. So I don't know if anybody has any ideas on how to make it so I can click a single button. Oh, and you can even, you know, look, this is a custom macro or whatever, and make a keyboard shortcut. Oh, nice. Okay. If anybody knows how to make it so it will not only open the command prompt, but also do the NASM and QEMU thing all with a single click, that would be nifty. Okay, but let's get on with the tutorial some more. Just go over some memory basics real quick, and then we'll try and get variables out of the way and get on with our lives. Let's just get something printed out to the screen real quick, I guess. For starters, OEO1. Let's have a look at that. Yeah, there's Happy Brother. Alright, so next, we'll try this experiment here. We'll just go put a data byte in there. Have a look at it. Whoops. No, brother, where did he disappear to? Let's have a look at our binary. There. Okay, so what's going on here? Okay, there's our 1. All right, and then we got some stuff coming after that? What's following it up? Okay, well, as we know, processor is expecting command followed by some data, and if we look here at number 1, it actually kind of stands for something. See, so the computer is now interpreting that we want to add some values or something. You know, it's making this complicated call or something, you see. So that is kind of overflowing into the next command. So, you know, we could, quick remedy would just be put that in there, or just as easily do it all. Whoops. Null terminated, you know. There we are. Have a value. Null terminated value. Oh, I don't want to look at it in binary. I want to look at it. Oh. Now there's a bit of residual. What's up with that? Okay. That 0 causes some print thing. Let's see. All taken care of. There's our happy brother. Good to go on that. So, yeah. So, let me go back here. Once again, look at our binary. We've got a value here. 1. We know where it is, right? For the most part. We want to, here, instead of, you know, moving, you know, of course, as you know, E would be, what, 14, right? H, you know, our teletype, right? And I'm moving a 1 in there. Whoops, sorry. Move a L. There's our value. Right, so same thing. But instead, I want to get this value down into here, right? Like, okay, so how can I do that, right? I know that according to our what we just saw over here in our B tab, it's at 0, 0, right? Well, that shouldn't be a problem, you know. Okay. But if I put 0 in there, you know, I'm just moving the value 0 in there. I need to tell it the 0 address or whatever, correct? You know, so that would be in brackets, right? So let's put a 0 in there, see what happens. Oh, no, not that. Let's look at it. Oh, no, that don't really work, you know. Oh, yeah, so can't get to that memory address. Here we go. O, X, O, O, O. Oh. Invalid, and that is why. Move AL, comma. Let's go back. Jump into questions here. Buddy bing, bing, bing. Okay. I don't think it it's swearing at me in Spanish now. Hang on. So clearly that's the same thing. That was the problem. It doesn't actually exist. This is a physical address. And hang on. So we need to know the physical address because we don't know where this program is actually being written into in memory. So we can be slightly more explicit with that. Let me just, we'll go up here and define the origin of our program to 0x77C00. There. So now it is a known value, right? Once again, let me save this. See, that doesn't fix it though. It's okay, and so, but now it's a physical. Now we know the actual address in memory, though. We should be able to pencil that in there. actually. Hard-coded in. Yeah, all fixed. So now we know, you see, our program starts physically in memory at this address, right? And now we're pointing to this address. This does not get written into the code. Of course, that's just a directive to the assembler, right? B10. Let's see, it starts at 1. There's not a bunch of labels or any of that stuff getting written in there, right? Let's see. So now then I could, here say H. Whoops. Let me get out of caps lock here. H. There, I guess. Okay, people. Nope, no H, and that is because, what did I do? Okay, that was a interesting bug to find because it didn't happen to me when I did the files individually. So the simple thing that I overlooked is right in here, I guess. Here, let me just make sure I'm saved. We'll have a look. Nothing there. Right, but if I go back to where I was before with a 1, oh, that's fine, right? So I guess when I put character in here instead of a value, apparently I no longer needed to terminate. Very strange. So then now the 0 apparently was regarded, messed up with the following code. So odd discrepancy there. Okay. Back to actually making this work. So yeah, speaking of making it work there, I removed the null termination and there's my character. Okay, working code. So now this is pointing here, right? Okay. Next thing. So yeah. So let's see. What do we got? DB. I got some data here in at this location. I could also go. Let me see if I can actually do that. There's my location. Can I add 1? Whoops. No, I can't. Place an add. Add to this one. Value of 1. Let me just see what happens here. Here. Operation size not specified. Okay, so add a byte. There, bite me. There, we have increased the value of the referenced bit of memory there. We wrote a H in at the first location, and now we have gone back and overwritten the H. Okay, awesome. So another thing, let's say I could put a label there. Text. My label. Okay. Let's get rid of the add byte. And here I should be able to just point to the label. Let's try that. Yeah. See? And then, of course, as we have discussed previously, there's no pointer in the code. It doesn't end up in the final render or anything. Decrease AX. That's interesting. H means decrease AX, if it were used in a different context. Very cool. Move AH, yeah. So there's no label in there to point to. Instead, it does the math, and it says later to jump or whatever. Okay. Jump to that address. Okay. To that specific place in memory, which we know is here, right? Okay, so furthermore, I guess I could go like that and go my text +1. See if that works. Maybe it does. Let's find out. Yeah. See, so prints. So then you could use a loop to iterate through the contents there. Right. I could go. Also, I could say, here's this is the end. Right here. Whoops. I don't think I can use end. It appears to be because it immediately turned blue. It tells me that it is already means something else. Okay, so whatever. Not blue. I don't care. There. Okay, great. So now I could likewise from here. It is just merely a reference to a place in memory. I could say not blue -2. Yeah. Yeah, why not? And there's my second L here. It's -2 from this place in memory. Yeah. Okay, so we're good on a few things. Also, let's see. Yeah, again, I know where this is. It is at the beginning of my program. Well, another one that. Hang on. I wasn't typing $$ for something for some reason. Yeah, we know our program begins at $. So that's another way to say go there. Okay, so then I could also oh yeah, this is an interesting thing too. So let's say you're watching the tutorials and I'm not going fast enough for you, and you're like, okay, I'm going to go find some other code examples out there on the internet, and you find something that looks like this. .data. And so the data, and then the tutorial is telling you how it's imperative that everything be there, and you have to clearly define your section.text like that. Okay, cool. Okay, so now good to go. So my data is where it's supposed to be, my text is where it's supposed to be, and let's run that code. Good to go. And whoops, not so good to go. I got some faulty character. Okay, so this is Rosetta Stone territory. We're taking code. Works fine in FASM, I guess. Here, but let us have a look, shall we? While we're here, I'm going to have a look at our binary. Okay, now what's happened? There's our hello. It's outside the boot sector now. All right. So apparently NASM recognizes. Hang on. NASM here. As soon as I type this, it recognizes it as we're in Notepad, but NASM apparently knew what to do with it too. It says when you do this, and if this isn't here, not a problem, right? So section data followed by text causes your data to be stored outside of the boot sector. Very odd. Okay, and then now, see, and okay, so now it's at a new address. Okay, but also, hang on, so I could go, where's my label example? My text, right? Let's do this. Jump to my text. Let's see what happens. Oh, I gotta have to say that it's a memory address. Yeah, that's fine. See, but if we're going to go grab some example off the internet written for NASM, here, let me just copy it from off screen and my section data and my section text. There. See, now it's going to break it, right? No worky. There you go. So that's what I'm trying to do. I'm trying to reconcile all these flavors of assembly that you find all over the place, right? So that is how you got to rescue it. Furthermore, let's see. So I've also run into some instances. Oh, okay. Well, let me just continue with our tutorial just a little bit further here. Also, in addition to using a label, we can turn this into a variable named Bob. Okay, so as you know, like here, I could go H E, that way. Here, let me just speed things up. That way, and individually want that way. All right. Or as in the previous here, combine them. Yeah. Okay, but a side thing. So it all comes out the same over here in the binary, Okay. Now, let's see. So I've got this defined as a variable. Let's just say, let's have a look at our variable Bob here. Yeah, Bob, that's fine. So likewise, we could go Bob plus 1 there. Yeah. Oh, wait. 1s. 1s is unknown. E, see? Yeah. So that's working with a variable. Now, I have run into instances as well where for some reason my variables would not work up here, and it was safer to declare my variables down here. I don't know what the reason for that. I'd have to go back and take everything apart piece by piece. But so therefore, it's kind of safe to just stick your variable names down there. So that is covering how to deal with variables. There's more, but that's kind of getting you in the ballpark so we can continue with some lessons involving the use of variables.